All right, beautiful people. So today's our last day on dilations, and we're going to focus on dilating in a coordinate plane. So the first thing I want to talk about is the rule for dilating in a coordinate plane. So, okay, so the rule for a coordinate plane dilation. So here's what we're going to do. We're going to dilate xy, which is a point, by the scale factor k, with the center of dilation at the origin. Let's talk about each of those pieces. So first, this is the original point that I'm dilating. Okay. Second, my scale factor is a variable, the letter k. And the center of dilation is at the origin. Over here on the left, I'm going to make a note. Unless otherwise specified, your center of dilation is usually the origin. Center of dilation, usually the origin. Okay, and it's going to make it so much easier for you to do that. Okay, and so when you're at the origin, or when your center of dilation is at the origin, then all of the lines from it are just straight lines. You don't have to worry about scaling for anything or adding or subtracting anything. So when you dilate your new point, so if you start with the point xy, your new point, p prime, is going to become k times x, comma k times y. Okay, and this k represents the scale factor. So whatever the scale factor is, you multiply both the x coordinate by it and the y coordinate by it. If you only multiply one of the coordinates by it, then you're no longer doing a similarity transformation. It will not become a similar object. If you only do one coordinate, then you might end up with a trapezoid when you started with a square, etc., etc. Okay, so this is the rule. Just the rule. Again, it doesn't really have a lot of meaning until we start dilating. So I'm going to draw some things in the coordinate plane. Okay, so in my coordinate plane, I've gone all the way up to 9 on the x-axis, and it looks like I've gone to 6 on the y-axis. Okay, so I've drawn my triangle. It's a right triangle, ABC, where A is at 2, 1, B is at 4, 1, C is at 4, -1. I want to scale this. Dilate. I'm going to dilate with origin as center of dilation and the scale factor of 2. Okay, now I know that I did a bunch of abbreviations right there because I didn't want to write everything out. So SF obviously stands for scale factor. COD stands for center of dilation. Okay, so if I'm going to dilate this with the center of dilation at the origin and the scale factor of 2, what I'm going to do is I'm going to create my image, A prime, B prime, C prime, where I multiply both the x, and the y coordinates by 2. So if I'm multiplying 2, 1 by 2 and 2, this becomes 4, 2. So 4, 2 should be my new A coordinate, A prime. All right. And then if I'm multiplying the b to get b prime, 4 times 2 is 8, and 1 times 2 is 2. So 8, 2. So 6, 8, 2. B prime. And then my new C prime coordinate is going to be 8, -2, which is here. Okay. And now my new triangle is supposed to be 2 times as big as the original. Obviously, my A and B are a little bit off on my scale because, my lines aren't perfect. But you can tell that A prime, B prime, C prime is obviously bigger, and it's scaled by 2. Okay, so again, all we're doing is we just multiply each of the numbers in the coordinate pair by whatever the scale factor is. Okay, let's try another one where our scale factor gives us something inside the previous one. Okay, so this time I scaled all the way to 4 on each axis, and then I put an NMK, where N is -3, -3, M is 3, 3, and K is -3, +3. I'm dilating with the center of dilation at the origin, and my scale factor is 1/3. So I'm going to start by doing my multiplication of each term. So N prime is going to be -3 times 1/3, which is -1, and -3 times 1/3, which is -1.